Hello everyone, I hope you all are doing great. So today we will going to do the Taylor's theorem. First, what is its statement? If a function fx defined in the closed interval a comma a plus h such that number 1 f to the power n minus 1 x exists and is continuous in this interval, and f to the power n minus 1 x possesses a derivative that is finite or infinite in open interval. Now what is this f to the power n minus 1? Means one time differentiation, two time differentiation, n minus 1 time differentiation is known as f to the power n minus 1 x. Okay, and the third point is p is any positive integer such that this p lies between 0 to n. Okay, then there exists at least one point theta such that this is the actual Taylor's theorem. uh, okay, so this is the expansion that fa plus h is equal to fa plus h f dash a plus h square by 2 factorial f double dash a till this. Okay, now we will going to see the proof. What is its proof? So from the first condition that the fn minus 1 x exists and continuous, so this implies that f exists, f dash exists. Okay, all are defined in this closed interval a comma a plus h. Now we have to consider an auxiliary equation function. Okay, so this is an auxiliary function. Let this be termed as phi x. Now phi x is equal to fx plus a plus h minus x, a f dash x plus a plus h minus x upon 2 factorial whole square. This is actually a pattern which is going on. Okay, starting from this will not contain any kind of a plus h minus x from this, and then this square till n minus 1, and the last term we are giving here as p. Okay, so here it is, fx, f dash x, f double dash x till fn minus 1 x, and here we are choosing a constant a. Okay, now where a is a constant chosen, so that f of a is equal to f of a plus h. Okay, so this constant is chosen. Okay, we have added this constant so that phi a is equal to phi of a plus h. You have to mark this equation as equation number 1 and this equation as equation number 2. Now from equation number 1, what we will going to do, we will replace the x terms to the a. Okay, x, here it is x. You have to substitute the value of x as a. So when you will do this, you will get this fi a is equal to f of a. Now here a will get cancelled and you will left with h f dash a, h square by 2 factorial f double dash a till the last term, that is a plus h minus, here you will be having a, so it will get cancelled, h upon n minus 1 factorial f n to the power n minus 1 a plus, now here you will be only left with h to the power p and a. Okay, so this is a this is the expansion after replacing x to a. Now we have marked this as equation number 2, as that phi of a is equal to phi of a plus h. Alright, so now what we will going to do, we will going to show that phi of a plus h will also having the same equation to that of phi of a. Okay, so here you can see that we have replaced a as a plus h and we are having the same equation. Okay, just in the above statement. So here till here this is very simple, we are doing nothing. Okay, now next we now observe from equation number 1 that phi of x is continuous in closed interval a plus h. Okay, because we have assumed that our function is continuous. So if function is continuous, corresponding to it we have a phi of x. This will also continuous. Okay, in this closed interval, since by hypothesis, like I have written that here, why this is continuous. Okay, now the second point is phi x is derivable in this. So if this is continuous, if the continuous property holds for phi x, then the differentiable property will going to hold as well. And then we have phi a is equal to phi of a plus h. Now you have to go to a flashback of what Rawls theorem. The three conditions are same which we have studied in the Rawls theorem. Okay, so in Rawls theorem we also have a function which is continuous in closed interval and it is differentiable in open interval, and we have a function a and b, f of a is equal to f of b. Then such that there exists a point, let's suppose c in that particular interval, such that that f of c is equal to 0. That was Rawls theorem. So this is same as Rawls theorem, that phi x is continuous in this interval, phi x is differentiable in the open interval, and phi of a is equal to phi of a plus h. Hence phi x satisfy all the three conditions of Rawls theorem, and consequently there exists at least one xi, okay, this symbol is known as xi, belongs to this such that phi dash xi is equal to 0. Okay, no problem till here. Now from 1, okay, the 1, what was the 1? This was this equation you have to differentiate. Simply what you will going to do, phi dash x हो जाएगा, f dash x, ठीक है, इसको now you have to use the product rule here, okay, till the last term. Okay, you have to differentiate it. When you will going to differentiate it, you will going to have this equation, and you will see that here this equation will get cancelled, this will get cancelled, this will get cancelled, everything will get cancelled, and you will be only left with phi dash x is equal to this one and this one. Okay, this means the last term and this term will only left, and rest everything will get cancelled. Now I am leaving this part to you solve it. You only have to differentiate it and cancel it. Okay, this much part I hope you all will going to solve. Now here now we have assumed a point xi. Okay, so we have to put the xi in place of this and we will get this. Like I have only substituted x is equal to xi. Now we know that the derivative of this phi this one, the derivative of xi is equal to 0. Now we have to do this term is equal to 0. Okay, so here it is written that, but here it is phi of xi is phi dash xi is 0. So this will we will getting that this minus this equal to 0. So this is equal to this. Now here this entire term will go to that side and you have to eliminate a. Okay, a is equal to this. Now here this term you need to remember that xi is, you have to put xi is equal to a plus theta h, where theta lies between 0 to 1. Okay, then in place of xi you have to put a plus theta h. After putting a plus theta h, you will end up having this. So we have a is equal to this equation. Okay, now what we need to do, the last step and the final step, is now putting the value of a in equation number 3, because we have assumed this constant a. So we have to go to the equation 3, put the value of equation a is equal to this in equation 3. You will get this complete expansion of the Taylor series, what you have exactly written in the statement. Okay, so here is the equation 3. I hope you will going to substitute the value of a here and you will get the same equation as it is written in the statement. Okay, so this was the Taylor's theorem. This is super duper easy. In the next video we will going to see the Maclaurin's theorem. Till then, stay tuned and keep learning. Bye bye.